Graph Theory, page 1, and I do apologize for my voice. Planning efficient routes is essential for business and industry with applications as varied as product distribution, laying new fiber optic lines for broadband internet, and suggesting new friends within social media websites. Each of these problems can be tackled using graph theory. Although this field of mathematics started about 300 years ago as a look into a mathematical puzzle, graph theory has exploded in importance in the last century due to the growing complexity of business and a global economy because we have computers that do the heavy lifting. Note, the diagram you see to the right is Königsberg Bridge problem, which laid the foundation of graph theory thanks to the approach by Leonhard Euler. So a graph consists of a finite set of points called vertices. I think many of you would probably figure out that the singular of that is vertex. And line segments called edges. These are not necessarily straight. Sometimes they could be curved. And edges connect pairs of vertices. An edge can represent a physical connection between locations like a street or pipeline, or simply that a route connecting the two locations exists, like an airline flight. So a loop is a special type of edge that connects a vertex to itself. I think you see a couple examples here. And I think it makes sense that a vertex will be represented by a dot. Now, we will say later on here that we are used to in geometry that if the intersection of two lines will make any kind of point, but that's not going to be the case in graph theory unless we draw the vertex. We're going to assume that it does not exist, even if those two edges cross. So on the graph to the right, label at least one vertex, edge, and a loop. So I think we've figured out that these are loops. Okay, which is a special kind of edge, right? This is an example of an edge DE. And of course, point D here is, or vertex D there is vertex. And there are many other examples we could have called on there. So a vertex could represent an intersection of streets, a landmass like Peoria and East Peoria, or a general location like work or school. Vertices are often, not always, connected by edges. Notice in the graph at the right that vertices only occur when a point is explicitly placed, like we just got through talking about, not whenever two edges cross. You will need to change your thinking from the geometry you learned in high school. Imagine a freeway overpass. The freeway and the street passing underneath the freeway would appear to cross on the graph, but it is not possible to change from the street below to the freeway at that point. In terms of a graph, there is no intersection. Therefore, no vertex would be placed.